Hey there, pre-calc friends. In today's video, we're going to keep continuing on with section 4.3. Remember, our goal here in this section, we're going to try to find the trig, SOHCAHTOA, and all the reciprocals of every single angle in our unit circle. We've done the first quadrant so far, right? We've done sine, cosine, tan for the 30, the 45, and the 60, and that's going really well. We've got the hand trick for a shortcut if you need it. But now we're going to try to find all the angles in all of the quadrants and try to do trig on them. So last time we realized, boy, if I even just threw a point at you, an XY coordinate, you could draw that point, draw the triangle, label the sides, and then do SOHCAHTOA, and you were good to go. So to continue on, let's do a little detective work. Here's a puzzle question for you. Example number 3, folks. Look at this one. I'm giving you an angle in the 4th quadrant, and I know that the sine of that angle, whatever the angle is negative 5 over 13. Your goal is, can you find the cosine of theta? Well, I don't really know what this triangle looks like, but you know what? The first thing I think I would do is I think I would just draw any triangle in the 4th quadrant. I don't know what size, how big, how small it is, and it doesn't really matter, but let's just draw a normal triangle in the 4th quadrant. Let's see. Starting from the origin, let's go out like this, like that. And that will give me a theta right here next to the origin. And I'll complete my triangle by always going perp to the x-axis. This time I have to go up and go perp to the x-axis there to make my right triangle. Awesome. Okay, I've got my triangle. Now I need to know the sides because again, my goal over here is try to find the cosine of theta, which means I need to know the adjacent and I need to know the hypotenuse. Okay, well, they gave us another piece of info, and that was right here. I know that the sine of this angle here is negative 5 over 13. All right, maybe that's going to help us, because remember, sine is opposite over hypotenuse. So let's see. I think the 5 is going to be the opposite, so I'll put the 5 over here, opposite of the theta angle. And the hypotenuse will be the 13, so that goes over here, across in the right angle. But now, which one's going to be negative? Because the negative 5 over 13, that could be either, negative 5 over positive 13 or 5 over negative 13, right? These all mean the same thing. So where's the neg really go? Actually, if you think about it, because the side on the right-hand side is going down, that's a negative. Y side, that is your negative. So your hypotenuse is positive 13, and your side on the right-hand side is the negative 5. Okay, can we use a little bit of Pythagorean so we can find this side? And when you do that, a squared plus b squared equals c squared, you'll see this is actually a nice Pythagorean triple. And I think you get positive 12. You can check that on your own. Okay, we are good to go. Shall we do it? Let's find the cosine of theta. So it should be adjacent over hypotenuse, which here would be 12 over 13. And we're done. Great. So do we know what theta is actually equal to? How much is theta? Well, the good news is here on this problem, it doesn't matter. We don't really need it. What did we do first? We drew a triangle in the 4th quadrant based on that. And then we tried to use the given information over here to label some sides. Once we did that, we found all 3 sides, and then we could answer the question and just do SOHCAHTOA. That's a neat question. So just being a little bit of a detective and using a little bit of logic. All right, now to continue forward. I need to really figure out where my trigs are positive and negative. In all 4 of these quadrants, is cosine positive? Is sine negative? How about tan? So what we're going to do is we're going to do a little bit of theory here. But I'm going to jump ahead for a second so you don't have to write all these down in your notes. But I just want you to know one really important thing. Whenever we draw an angle in our coordinate plane, no matter where the triangle is, here, or there, because to find the hypotenuse, we are always using Pythagorean theorem, which means we're always doing a square root. When you take a square root, you get a positive number out, right? The square root of x squared plus y squared, which is the hypotenuse, that's always going to be a positive number. Or if you think about it, back here in this circle over here, these hypotenuses that we are drawing are almost like, well, like radiuses of a circle. And the radius of a circle is also always positive. So my point here, friends, is that this part right here, when you draw a triangle, your hypotenuse is always positive. always positive, no matter what. The sides, over here and over here, they can be negative, sure. But the hypotenuse is always positive, no matter what. Okay, here's why I tell you this. Because now when you're going to do SOHCAHTOA, if SOHCAHTOA is opposite over hypotenuse, or like we found yesterday, it's the y value divided by the h value, if I give you an xy point. Do you notice that, like we said, if the hypotenuse is always a positive number, always positive, are you a believer that if my y value, my opposite, is negative, can you see, because it'll be a negative divided by a positive, my sign will also be negative. If the y is negative, my sign is negative. And similarly, what if the y value was positive? That's positive divided by positive. That's also positive. So I feel like right here, if your y value is positive or negative, then your sign is positive and negative. And put off to the side here that the sign and the y value are pretty much near cousins to each other. Y and sign are very, very much close to each other. So if one of them is positive, then the other one is positive. If one of them is negative, then the other one is negative. So now we know in the different quadrants, if the y values are positive in that quadrant, then the sign has to be positive in that quadrant. Okay, and similarly over here on the right side, same thing with cosine. Remember, if the hypotenuse is always positive, like we said up here, then if the x-coordinate is positive also, then the cosine is positive. If the x-coordinate is negative, then the cosine is negative. Okay, so that leads us down here. Two really, really important things to know, and I'll put stars right next to that for you. If you know the x value is positive, then the cos is positive. If you know the x value is negative, then the cosine is negative. Okay, so the cosine and the x values are close cousins with each other. Okay, so always put x with cosine and y with sine. Great, so now, do you remember this diagram that we showed when we talked about the unit circle for the first time? And we said, wow, look at these neat things. First of all, we have all the radians all around the entire circle, and that's great. But we said, look at these Roman numerals. What did these mean? And someone pointed out, yep, those are the quadrant numbers, right? Quadrant 1, 2, 3, and 4. And then we looked up over here, and we're like, what are these plus, comma, plus, and negative, comma, plus, and, you know, all around here? What does that mean in that quadrant? And someone also pointed out that those are the x, y signs. So in the first quadrant here, x is plus, y is plus, meaning x is positive and y is positive. That kind of makes sense because when you graph these points, like in the second quadrant, your x would be negative, your y would be positive. And down here in the third quadrant, yes, your x is negative and your y is negative. And finally in the fourth quadrant, x is positive and y is negative. That's great. Okay, so that means x and y. But didn't we just learn about the trigs that are like close cousins? So not only just x and y here, but trig. In the first quadrant, the cos is positive because cos was x, right? The sine is positive because sine was y. And as I work my way around, in the second quadrant, the cos is negative because the x is negative, and the sine is positive. And work your way around. In the third quadrant, cos is negative, sine is negative. And in the fourth, cos is positive, sine is negative. Now, you can memorize that if you want, but let me give you one of the best shortcuts to help you remember which trigs are positive in which quadrants. Ready? If you can remember this, you are golden. ASTC, or all students take calculus, which hopefully you will after pre-calculus. What does that mean? Okay, if we start in the first quadrant, folks, and we work our way around in the normal order that we draw angles, counterclockwise, and we draw A, S, T, C. These all stand for the trigs that are positive. This is all about which ones are positive numbers in these quadrants. So for example, A means all. All trigs, meaning sine, cos, tan, all three of those trigs are all positive. But remember, not just all three, but then also all of the reciprocals, right? So really, all six are positive. So don't forget those extra three. In the second quadrant, folks, S. S stands for sine. So the sine is positive in that quadrant, which also means the cosecant. And so on and so forth, folks. So you can work your way around and see that, for example, the T in the third quadrant, because it's T, it means tan. Only tan is positive, and then also cotan. And finally, the C in the fourth quadrant means cosine. So only the cosine is positive, and therefore also secant. Now, when I say the cosine is positive, that means if you are in that quadrant, in quadrant 4, and you're talking about the sine, if he's not cosine or secant, he's got to be negative. So only the cosine is positive, and the secant is positive, which means all the other 4 trig functions have to be negative. All right, let's play. So all students take calculus. Ready? Let's just work on this example up here. Now, without putting these in a calculator or even actually analyzing these, I just want to know if each of these expressions are positive or negative. Okay, I'm going to put my all students take calc shortcut here. And let's do number 1. Let's first figure out where the heck is 165 degrees. Let's see, 165. I think that's in the second quadrant, right? That's in the second quadrant. So my eyes are looking over here. And in that quadrant, what's the one that's positive? S for sine. Okay, that means sine is positive. And what am I looking here at number 1? I'm asking for the sine of 165. So because sine is positive in that quadrant, I know that the sine of 165 is positive. That one's done. So find the angle, figure out what letter of ASTC you're playing with, and then you can determine if that trig that you're being asked is positive or negative. How about number 2? On number 2, you're trying to figure out that cosine of 5 pi over 6. Well, we figure out where that one is. 5 pi over 6. That's like 150, I think, and that's also in the second quadrant. So remember, in the second quadrant over here, only sine and cosecant are positive, which means I'm asking for the cosine. So therefore, if the cosine is not sine or cosecant, he must be negative. So therefore, number 2 is negative. And finally, number 3, 4 pi over 3. That is way over here in the third quadrant, friends. In the third quadrant, that's tan, T for tan. So tan is positive and cotan. And what's it asking for? For tan. So therefore, I know it's going to be positive. Great. So that's how we can use signs to help you out to figure out what is positive or negative. But all students take calculus is one of the best shortcuts that we have right now. Good. One last thing before we go. I'm going to skip ahead a little bit, and we're going to talk a little bit about reference angles to help us figure out how can we find the trig of really big angles. Once we get past the first quadrant, we're going to need these little reference angles to help us out. Reference angles, basically, as you see here, are little helpful small angles, acute, meaning like less than 90, that can be replaced the actual big angles when I try to find the trig of them. For example, if I gave you 30 degrees here in the first quadrant, I could probably find sine, cos, or tan using the hand rule or the chart. But if I try to find a bigger angle like 210 degrees, well, I can't really build, I'm trying to build a big triangle here with, I can't build an actual right triangle and try to do SOHCAHTOA on it. It just doesn't work. It's too big. So what we have to use a reference angle. And the reference angle is basically how far are you to the nearest x-axis, right there in red. How far are you? On the purple angle, here's your reference angle. How far are you to the nearest x-axis? So for example, can we try, how about 160 degrees? What's the reference angle to 160? How far does it take to get back to the nearest x-axis? And that will be your reference angle. So let's draw 160. All right, 160 is right over here or so. Okay, that's 160 degrees. If I eventually want to do sine, cos, or tan on that, I'm going to need to use the reference angle that's nearest the x-axis. Well, that's right here. That's the nearest x-axis distance. How far is that? Well, let's see. If I know that a full semicircle is 180, and I'm only going 160, how much do I have left here as my reference angle? Well, okay, so I drew my angle. The reference angle amount is how far it is between that ray that I drew here and the actual nearest x-axis. And here, did you get it? It's 20 degrees. So my reference angle for 160 is 20 degrees. And I'll need that later when I try to do SOHCAHTOA on that angle. Instead of using 160, I'll probably do SOHCAHTOA on the 20 instead since it's smaller. But we'll deal with that later. Let's practice. Let's find a couple of reference angles here. All right, examples 1 through 5. I'll start you out on a couple of them and see if you can do the rest on your own, friends. All right, number 1. Let's try to find the reference angle for 200 degrees. So why don't you go and draw that angle first, 200 degrees. That is past 180, so it's right about over here. There's 200 degrees. Okay, my reference angle should be the angle nearest the x-axis, right here. And even though I'm going backwards to get to the x-axis, it's always going to be a positive numbers. Reference angles are always positive. Even if I'm going the opposite direction to find it, don't worry about it. It's always a positive number, a positive angle. Well, I went past 180 and I went 200. So how much past 180 did I go? I went 20 degrees. So my reference angle there would be 20 degrees. How about number 2? Can you draw 340 degrees? I think that's in the fourth quadrant. Let's see. 90, 180, 270, and maybe about 70 more. Okay, that's 340 degrees. My reference angle would be the distance to the nearest x-axis, which is right here. Always x-axis. Well, how far is that? Let's see. I traveled 340, and I know if I kept going all the way, I would get to 0 or 360. So how much further do I need to go? Oh, it's 20 degrees. Now, have you noticed the past 3 examples have all said 20 degrees? That's just a coincidence. It's not always going to be 20. But there you go. There's a reference angle. 340 is a big angle. So we're going to use the 20-degree reference angle later to help us find trig. Let me give you one more in radians, and I'll let you try the last 2 on your own, guys. 3 pi over 4. Let's graph it. All right, unit circle. Let's see, 3 pi over 4 is, I think, right over here in the second quadrant. Okay, reference angle should be to the nearest x-axis, which is right here. All right, now to think about this, again, like I did before in the previous examples, when I did 160, I was almost at 180. Here, I'm at 3 pi over 4. I'm almost at pi. Well, how much further do I have to go to get to pi? Oh, that's hard with these fractions, right? I don't want to use degrees because I don't want to cheat. I want to just try to use radians and challenge my brain. Well, if I go all the way to pi, in terms of 4s, pi is 4 pi over 4, right? So if I already went 3 pi over 4, how much more do I have to go to get 4 pi over 4? I have to go just 1 pi over 4. So the reference angle, the distance from that angle to the nearest x-axis, my reference angle would be 1 pi over 4. Degrees? I can do radians. All right, why don't we pause the video and can you try number 4 and number 5 on your own? What are the reference angles? Good luck, folks. Okay, welcome back. I drew the angle for number 4, and 179 landed me right about in the second quadrant, almost all the way on the left side of the whole coordinate axis. Okay, so my reference angle there in red is how far away? I am 1 degree away. So my reference angle for 179, the distance to the nearest x-axis is 1 degree. Number 5 is kind of challenging because to draw 422, I'm actually going to go past 1 full circle here because 1 full circle is 360. So I get past past 360, and I went here. Okay, so there's 422. Reference angle, again, back to the nearest x-axis would be this friend here. So how far is that? Well, I guess I need to think about when I traveled from 0 to 360, I got that far. How much further after 360 to get 422? Let's see, I went 360, so how much further to get to there? Maybe I can subtract, and I would get 62 degrees. So this angle here is also like 62. This is like coterminal degrees, if you remember coterminal. So now, if you can see, that angle here is basically 62. So my reference angle to get back to the x-axis would indeed be 62 degrees. And that's how we do reference angles. And again, we'll use these reference angles later to help us do trig on the bigger angles in quadrants 2, 3, and 4. So for today, reference angles, and all students take calculus, and you guys are great. Awesome, and we'll see you next time.